Every decade in aviation has produced machines so bold they seemed impossible. From giant asymmetrical warbirds to futuristic hydrogen hyperjets, each one challenged both the eye and the rulebook. Between epic failures and breakthroughs that shaped the future, you're about to discover secrets you won't believe. In 1938, Germany unveiled the BV 141, a reconnaissance aircraft so unconventional it seemed impossible. Its cockpit sat in a glass pod on one side, while the fuselage and radial engine balanced the other. This asymmetry was not a mistake. It was an ingenious attempt to give crews panoramic visibility without sacrificing aerodynamic performance in long-range observation missions. Powered by a BMW 801 radial delivering 1,538 horsepower, it could exceed 232 knots, climb to 32,800 feet, and travel over 1,026 nautical miles. The offset cockpit provided unobstructed views for spotting enemy positions, guiding artillery fire and photographing targets with exceptional clarity. Although the BV 141 performed well in trials, it was doomed by resource allocation and the Luftwaffe's preference for the Focke-Wulf FW-189. Even the improved BV 141B, with more power and refinements, could not secure mass production. Only a handful were built, and they served briefly before fading from operational use entirely. Despite its short career, the BV 141 remains one of aviation's most memorable designs. Its bold disregard for symmetry demonstrated that unconventional thinking can produce practical results. The lessons it offered in visibility and crew efficiency would echo in later aircraft, just as post-war Europe would soon create an amphibious design of equal elegance and versatility. Emerging in post-war Italy, the Piaggio P136 brought style and adaptability to amphibious aviation. First flown in 1948, it featured an all-metal hull, inverted propellers mounted aft of the wings, and retractable landing gear. This unusual pusher configuration kept the propellers clear of water spray, reduced cabin noise, and gave the aircraft a sleek, modern profile unmatched in its class. Its gull-wing design improved aerodynamics and enhanced stability both on water and in the air. Early versions carried two Franklin engines rated at 215 horsepower each, later upgraded to twin Lycoming units producing 340 horsepower apiece. This boosted its top speed to about 181 knots and extended its range to roughly 783 nautical miles. The P136 could climb to over 25,600 feet and carry up to 5 occupants plus baggage, or serve as a medevac platform with space for stretchers. It was operated by the Italian Air Force for search and rescue, while civilian owners valued its versatility for coastal patrols, recreation, and island hopping routes in the Mediterranean and beyond. Sold in the United States under the name Royal Gull, it found a niche market with pilots seeking refined amphibious performance. Its combination of elegance, rugged construction, and practical design made it a symbol of Italy's aeronautical rebirth. As the jet age accelerated, aviation minds would turn toward vertical flight and futuristic shapes, unlike anything before. In 1959, France shocked the aviation world with the Snecma C-450 Coleoptère, a vertical takeoff jet that looked more like a rocket than an airplane. Its circular wings surrounded the fuselage, creating an airborne ring that turned heads wherever it appeared. Designed for operations without runways, it promised unmatched agility in confined spaces, if its radical design could be mastered. Powered by an Atar-E-Vi turbojet producing 1,536 horsepower, it measured 26 feet in length with a 14-foot 9-inch wingspan. It reached speeds of over 216 knots and climbed vertically to more than 2,600 feet during test flights. The enclosed ring wing was intended to improve lift and stability, but it also presented unique control challenges. Pilots found the transition between vertical and horizontal flight to be unstable, with limited instruments making orientation difficult. During its 9th free flight, instability led to a crash from which the pilot survived with serious injuries. The accident, combined with budget constraints, ended the program before the concept could be refined for operational use in military or civilian roles. Though it never entered service, the Snecma C-450 Coleoptère remains an icon of aerospace boldness. Its annular wing design inspired later experimental concepts and underscored the risks of pushing flight envelopes. From a ring that reached for the sky, we turned to a grounded workhorse design whose strange appearance belied its practical mission in the fields. The Transavia PL-12 air truck debuted in 1965, instantly standing out as one of the most peculiar agricultural aircraft ever built. With its high wing, twin vertical tails, and abrupt nose profile, it looked more like a flying machine from a comic book than a crop duster. Yet behind the odd lines lay a purpose-built design for maximum visibility and efficient ground operations. Powered by a Rolls-Royce Continental Saint-Malo 0500-20D engine producing 300 horsepower, the air truck cruised at about 103 knots and climbed to ceilings above 9,800 feet. It could haul over 2,000 pounds of chemicals or liquids, making it a formidable tool for aerial spraying across large tracts of farmland. Its twin-tail booms and open rear fuselage allowed easy loading of cargo or stretchers, giving it versatility beyond farming. Configurations ranged from two-seat passenger layouts to ambulance and survey platforms. The wide cockpit view made it safer for low-level flying, where precision passes over crops were essential for effectiveness and safety. Although production ended in 1985 after just over 120 units, the air truck remains a symbol of unconventional utility. Its rugged simplicity, ease of maintenance, and distinctive look kept it flying in various roles worldwide. From the farmlands, our journey now returns to the skies for an aircraft whose massive frame carried space shuttles across continents. In 1974, the United States transformed a Boeing 747-100 into something no airline had ever imagined, a flying piggyback for the Space Shuttle. Reinforced fuselage, twin vertical stabilizers, and massive mounting struts turned this airliner into a space program workhorse. Its sight in the sky, carrying a shuttle on its back, became an enduring symbol of aerospace ambition. 4 Pratt & Whitney JT9D7J turbojets, each producing 50,000 pounds of thrust, gave it the power to lift the orbiter and cruise at 248 knots when loaded. With the shuttle attached, its range dropped to about 1,150 nautical miles and its ceiling to 15,100 feet, requiring multiple fuel stops on cross-country ferry flights. Operating such a large, ungainly load demanded special handling skills. The altered aerodynamics changed balance and response, meaning every takeoff and landing was a high-stakes event. Still, the shuttle carrier aircraft ferried orbiters between launch sites, refurbishment facilities, and public display events, safely logging decades of service without losing a single shuttle in transit. By the end of the shuttle era, one aircraft was retired to display with a replica orbiter, while the other remains preserved in California. Its unique role bridged aviation and spaceflight, proving the value of engineering adaptation. From this massive sky hauler, we shift to a slender experimental plane that rewrote endurance records for piston-powered flight. In 1984, an unassuming composite aircraft took flight from the Mojave Desert, destined to achieve the impossible, circumnavigate the globe without refueling. Designed by Burt Rutan, the Voyager carried fuel in almost every surface, trading speed for range in a bid to push piston engine endurance farther than ever before attempted in aviation history. 2 engines, a 130 horsepower Teledyne Continental. O200 and a 110 horsepower IO200 provided thrust for its record-setting voyage. With a wingspan of 111 feet and an ultralight frame, it maintained a cruising speed of about 106 knots, staying airborne for more than 216 continuous hours. In December 1986, pilots Dick Rutan and Gina Yeager launched into storms, turbulence, and fatigue, covering more than 22,600 nautical miles. The cramped cockpit offered no luxury, but their determination and skill kept the Voyager aloft, completing the first nonstop, unrefueled flight around the world and etching their names into aviation legend. The Voyager's success proved that innovative design and human perseverance could shatter perceived limits. It became an enduring symbol of exploration and problem-solving under extreme constraints. From its feather-light wings, our path now leads to a modern semi-rigid giant that reimagined a gentler, quieter way to fly for hours over diverse landscapes. In 1997, Germany revived the grandeur of lighter-than-air flight with the Zeppelin NT, a modern semi-rigid airship blending nostalgia with advanced engineering. Stretching 246 feet in length, It soared gracefully at altitudes over 8,500 feet, offering a quiet, stable platform for observation, tourism, and environmental research in skies around the world. 3 Textron Lycoming IO, 360 engines, each delivering 200 horsepower, propelled it to a top speed of about 67 knots, with a cruising pace near 62 knots. Able to remain aloft for 24 hours and cover nearly 486 nautical miles, it maintained stability in varied weather, making it reliable for both commercial and scientific missions. Its semi-rigid structure bridged the flexibility of blimps and the durability of classic rigid frames. The spacious cabin seated 12 passengers and 2 crew members, with a payload of nearly 4,400 pounds. Large panoramic windows offered unmatched visibility, while its low-noise propulsion minimized disturbance to wildlife and urban environments alike. With only a limited number built, the Zeppelin NT remains a rare sight yet an unforgettable experience for those who fly aboard. Its endurance and elegance symbolize a softer, slower side of aviation. From this serene giant, we move to a cutting-edge electric craft, promising emission-free vertical travel over busy cities and coastal regions. In 2017, Germany introduced the Lilium Jet, a fully electric VTOL designed to revolutionize short-range air transport. With a futuristic profile and emission-free operation, it aimed to connect urban centers and regions with unprecedented speed and efficiency, carrying 6 passengers and 1 pilot in a cabin designed for quiet, comfortable travel. Its 36 ducted electric fans were mounted along the canards and main wings, providing vertical lift for takeoff and landing before tilting forward for efficient horizontal cruise. This arrangement allowed for a smooth transition between flight modes, while enhancing safety through motor redundancy, ensuring continued flight even if 1 or more fans failed. Delivering 320 kilowatts of total power, the Lilium Jet cruised at up to 162 knots, with a planned range of about 162 nautical miles. Advanced lithium-ion batteries with silicon anode technology sustained the high power demands of vertical operations, while offering rapid recharge potential for high-frequency service. Test flights began with smaller prototypes, but setbacks including a hangar fire in 2020 slowed progress. Despite financial hurdles, its vision inspired global interest in sustainable aviation. From this quiet, futuristic flyer, our journey turns to an even more unconventional craft. From Japan came a vision unlike any conventional aircraft. The Flying Gondola, a lightweight VTOL concept designed for serene panoramic travel. Its cabin, resembling a suspended glass pod, promised passengers a gentle ride, with an unbroken view of the horizon, the sky above and the world below, redefining what personal aerial mobility could feel like in crowded urban landscapes. The system called 4D gravity kept the passenger seat level at all times, neutralizing turbulence and sharp maneuvers. 8 electric motors were split evenly between 2 tilting wings, each holding 4 propellers that shifted position for vertical lift or forward flight. Even in adverse weather, stability was maintained and landings were cushioned for comfort and safety. This early prototype, weighing less than 20 pounds, measured about 5 feet in both length and width. Operated remotely, it demonstrated full autonomy without requiring an onboard pilot. In partial failure scenarios, the remaining motors could sustain a safe landing, proving its redundancy-focused architecture. Designers envisioned scaling it up for urban commuting. Though still in concept form, the Flying Gondola sparked curiosity for its blend of technology and leisure. It offered a glimpse into a future where aerial transit could be as relaxing as a ride on a Ferris wheel. From this hovering pod of tranquility, our story accelerates into the realm of hypersonic, hydrogen-powered flight connecting continents in mere hours. In the 21st century, Europe unveiled Destinus, a hydrogen-fueled hyperjet aiming for Mach 5 travel with 0 carbon emissions. First flown in prototype form in the early 2020s, it promised to shrink the globe, linking cities like London and Tokyo in under 2.5 hours, while cruising above 65,000 feet in the thin, cold stratosphere. Built from heat-resistant, lightweight materials, its aerodynamic shape minimized drag at hypersonic speed. Liquid hydrogen powered a combined cycle turbojet, delivering clean combustion and exceptional efficiency. The design targeted safe, stable flight at extreme velocities, supported by systems capable of withstanding the immense thermal and structural loads of such missions. Autonomous navigation allowed real-time adjustments for weather and air traffic, optimizing routes and managing engine performance. This reduced pilot workload and increased operational safety, making it suitable for both civilian and strategic applications. With its projected range of thousands of nautical miles, it could redefine intercontinental travel standards. Still in testing, Destinus has secured backing from European governments and aerospace firms, aiming for commercial service between 2032 and 2035. As it races toward that future, the aviation world turns to another hypersonic challenger, an American project blending military potential with commercial speed. The Hermeus quarter horse is a hypersonic jet project aiming for Mach 5 capability, merging military strategy with commercial potential. Backed by the United States Air Force, it employs a turbine-based combined cycle engine able to transition from subsonic to hypersonic speeds. This innovation could enable flights from New York to London in under 90 minutes, reshaping both defense and global business travel. Its lightweight frame uses high-temperature composites and titanium to endure the heat and stress of extreme velocity. The aerodynamic design reduces radar signature, giving it potential stealth advantages. Testing focuses on smooth transitions from turbojet to ramjet modes, maintaining stability and control in conditions where the margin for error is measured in seconds. While defense missions are a prime target, Hermeus also envisions civil applications, such as urgent cargo delivery or rapid response transport. The quarter horse could operate at altitudes above 65,000 feet, combining range and speed to outpace any existing aircraft in its weight class. Such versatility positions it as a disruptive force in aerospace technology. Initial flights will be unmanned, gathering data for future crewed variants. Full operational integration is projected between 2032 and 2035. With the quarter horse, the boundaries between military necessity and civilian convenience blur, offering a glimpse into a future where hypersonic travel becomes an everyday reality. Exploring these improbable machines shows how aviation has always been a laboratory of dreams and risks. Which aircraft surprised you most? Tell us in the comments. Like this video to support more stories like this. Not subscribed yet? Join our crew for future episodes. Share this with fellow aviation fans. Watch the videos on screen now and keep flying through these fascinating aircraft. Bye-bye.